Started. Why don't we start with Anant today and go down?
Thank you. Yeah, personally, I found the paper really hard to read. There's two terms that I don't quite understand. So just going to the glossary, was reading through it. But I found the two sort of diagrams, the taxonomy of attacks diagrams, one of the predictive AI systems and the other generative AI systems, to be quite useful to get a gist of the various attack vectors and the categories that the paper tries to put them in. Uh, uh, and Also, like while I started to read this earlier, I found myself wanting to watch the properties video on introduction to LLMs again, and it was quite useful as sort of in the end he goes through all of these different attack vectors for LLMs, and I found it interesting. For example, the sort of base 64 encoding could sort of jailbreak these LLMs to, especially these private LLMs, to sort of uh, give answers, generate answers that are I'd say that it's safety guardrails that it's put under, and also he talked about, which I didn't find in this paper. Maybe I will put it more carefully about something called as a universal transferable suffix, which was like a single sort of long string that would jailbreak uh, all of these different kinds of private LLMs. I think that was interesting, and also I found myself thinking, well, I was trying to understand these different attack vectors, especially with respect to like different data poisoning or risk model poisoning, uh, and like specific, targeted or indirect poisoning type vectors. It sort of made me think if these intelligences, at least the modern versions of these LXMs, are like sort of like a primordial sort of intelligence that you don't necessarily have to use for accuracy in their or factual accuracy in their capabilities as opposed to like more creative aspects of it. I mean, of course, not on facts that are easily verifiable, or not that you can verify it yourself, but just generally a form of thinking. These are more useful as sort of your creative thinking partner, and so those attack vectors, while it could have serious, I guess, if you use them for serious critical automation, like workflow automation techniques, where the sort of output is used critically in workflow, it could be serious. The sort of privacy aspects of it, I found to be more got my alarm bells ringing in some sense, especially like things like uh, something I think even people call it like I think somewhere think about something along the lines of data extraction, where we could reconstruct the sort of attack vectors where the adversaries could construct uh, personally identified information, or like some sort of or include malicious link in the sort of the prompt generator that when the user access it can use to extract other types of information from the devices. I thought that was quite seemed like a serious attack vector to think about and to see how one can potentially fight it. Uh, yeah, I guess I'll stop there. But also one piece of information that we think about was like uh, all of the data. I guess the Llama 2, when the discussed was about the 10 PB of data that was introduced to about 140 gigs of parameters, uh, was scraped from the open internet, and the internet is consists of previous like a lot of like SEO type information and a lot of junk information of itself, even without these data poisoning attacks. So just sort of just like think about that, and when you think about uh, blockchain related information that is like slightly more cryptographically verified and signed, it's like hard to speak and not to poison. But of course, that's quite rudimentary, and it's not quite available for all kinds of data yet. But just thought about speculatively what it might evolve, but I'll stop there and pass it down to Anuraj.
Uh, yeah, the document is quite comprehensive, and uh, so basically, I went to the glossary and then was randomly jumping around here and there. So I don't have any specific details about what I read, but I kept thinking about if in 5 years, how are people going to train new models? Because like everything on the internet will be generative AI stuff, and then like basically uh, it will be trained on uh, generative AI stuff, I think. I don't know. And then basically, how are they going to identify if something is adversarial? If like you really don't know what is good stuff there on the internet. And then basically, I don't think we even understand how this generative AI stuff is like generating all the stuff, and then how are you going to uh, like know what to do when such an attack is taking place. Yeah, those were my thoughts, and with that, passing on to Ben.
I mean, it is very interesting. I find it, I didn't read. I mean, I read what I could, but I just find it fascinating what sort of wide surface area for attacks you have here, because I wouldn't, I don't know, I wouldn't expect it to be so huge, but like everything from the training data to like finding particular evasions, um, it's just fascinating how big it is. I actually think that the current sort of way we're doing this machine learning stuff of like, all right, just upload the internet into it, and then you have your model, and you can use the Chat GTP thing on OpenAI from whatever, and you can create a wrapper around that, and then there you go. I actually think that that's like a like level zero non-adversarial sort of naive way of doing it that does have some interesting results, but I actually think the next decade or so of this is going to be going backwards and sort of doing the parts we sort of skipped over by ingest everything, don't care, to actually coming up with being much more careful about the data that goes in. Maybe I could imagine some kind of like open source models where like the training data is public, and this gives you both protection against poisoning, but also protection against legal attacks if like people are worried about copyright of input. You could make sure all the input data is like public domain, and yeah, that'll mean a lot less data than consuming the entire internet, but I believe I suspect there are ways around that. And then you have like maybe you could do some, and maybe this is unnecessary, but some kind of cryptographic method of like proving that you have this model, and the only training data went into it was this list of public domain data, or non things that are non-poisoned or whatever. Um, So maybe I think that will be the future, as opposed to just being more naive and continuing to hammer it with just everything you can get your hands on. Because I suspect you're gonna run into not only just diminishing returns but negative returns with that, where it peaked and now it's going down because it keeps ingesting garbage. Um, the other sort of thing is I make this paper makes me think about is it's very interesting to use these sort of attacks as like models for how the thing actually works. Like, privacy attacks means you can extract some of the training data, and it's always been questionable, like how much of the training data is in the machine or not, and how much could you actually recover if you tried hard enough. And it's interesting because basic what is it information theory says that it's not just a copy of the training data. That because it's not big enough. But there is the thing about information theory and other sort of very abstract global limits is you often when even if the proofs are totally correct, you often don't understand sort of where the limits really are practically. So maybe, yeah, the model doesn't actually, I couldn't recreate every part of its training data exactly, because you can't compress exabytes of data into gigabytes of data reversibly. But maybe, it gets you 9/10 of the way there, using, I don't know, some properties of the data we're not even capable of imagining. So I think that's very interesting. And like all these like data poisoning and such, it's fascinating. Like, because you almost have like a chaotic system here where very small changes to the input can cause, very large changes to the output. So in some sense, the models are, unstable, which is that sort of a property of like all sufficiently complicated systems, but is also like, not particularly nice to deal with. So yeah, those are the thoughts I had on this, and I'll pass it down to Scott. Hello, Scott, you there? Can anyone hear me?
Yeah, we can hear you. All right, Scott, we'll circle back to you in case he's stepped away or something. Yeah, I too was like not necessarily surprised, but sort of like when you go to like a big natural scenic spot like the Grand Canyon, and you're impressed by the vista of just how big the landscape is, like just how much actual stuff there is. So not necessarily surprised by the size of the attack surface, but just like impressed by the grandeur of the landscape itself. The big thought I had reviewing this was, in a way, just how unsurprising it was. Where previously with traditional computing, whenever I used to read anything about security and attack surfaces, I was always struck by how unfamiliar it was. Like the sort of the concepts and architectures around which traditional computing is built, including in this sense, crypto, means that all the attacks kind of seem like weird and clever, like magic tricks. Like, whenever you look at something like buffer overflow or SQL prompt injection attacks, things like that, it's like you're learning something about a weird machine. Like, so you're learning about a world of phenomena that's like very alien, and you kind of have to wrap your mind around it and understand it. So to be either a good attacker or a good defender, you have to learn to think with very alien constructs. Whereas here, everything seems extremely familiar, which makes sense because this is trained on humans and human behavior. So the attack and defense landscape is basically the same, with a few differences. It's the same attack and defense landscape humans use on each other. Like as I was going through and cherry picking random things to look at, I was looking at like how does this manifest in humans? And a simple example, I think Anant also pointed this out, is the universal prefix prompt example, which is you can bias the output by telling the LLM to start every response with affirmative, so like a yes, right? So you can see how this would work. But the interesting thing is, this is exactly the same thing acting teachers used to teach improv techniques, right? So most people by nature are a little conservative and risk averse. And if you present them with something unfamiliar, their reaction is to say no and back away and become defensive. So in improv theater, they teach you to use the technique of yes and. So you're on stage with somebody else, and the other person starts an improv scenario, and your only meta instruction is whatever you do, make sure it fits into the yes and framework, as in you build on what the other person is saying or doing. You kind of like run with the premise that they've started. And this takes the whole improv performance in an interesting direction. Now, this prompt injection attack, which in the taxonomy, I guess, fits into the integrity phase, is you want the LLM to be unduly positive and always sort of agree with everything and say yes and sort of build on whatever the prompt is saying, right? So I can see how this AI attack is sort of like modeled after a human attack. So if you invisibly inject meta instruction of begin every answer with a yes, you suddenly sort of like undermine the integrity of the whole model, because now it's like extremely positive biased and is saying like, I don't know, meaninglessly optimistic things that can go badly wrong. And I think we've all had experience already of how you easily can switch polarity in an AI model just by, like, if you correct a single minor mistake in a response, it'll say, yes, I was wrong, and then like switch the whole answer. So it's fragile in that sense. And I was thinking a lot of other things also look like human attacks, like some things like, weirdly obfuscated trigger words that make poisoned responses come out. So this is like, what was that? The targeted poisoning, I think, is the phrase they used. It's like, it's not that the entire data is, or response envelope is contaminated. Like most of the time, the model produces relatively reliable and trustworthy examples or answers, but in some narrow areas you want to like compromise it, like, so maybe you want it to be accurate in everything except whenever it's asked about like chemistry, you want it to give wrong answers that are dangerous and like suggest poisonous substances and so forth, right? So that would be a targeted poisoning attack. And the idea of like using various weird trigger words in the prompt injection, that sounds like hypnotism to me. Like, I don't know if hypnotism actually works like this or whether this is a movie trope, but the idea that there's like a normal person and you sort of like condition them that whenever they hear a particular word, like maybe banana, they suddenly change behavior and turn into an assassin and go try to kill somebody. I think this was the plot of the movie Zoolander, where the model who's like in a modeling show, whenever he hears a particular word, he has to go kill the Malaysian prime minister. That's the plot. So I think this pattern is general. You look around and look at all these attacks and defenses, and it all looks weirdly familiar, because this is how you would manipulate people, and this is how you would defend against being manipulated by people. And the taxonomy is also a very human taxonomy. So you've got like the white box, gray box, black box. That's kind of the same thing as like being attacked and manipulated by a complete stranger in, for example, an online scam, versus being manipulated and attacked by somebody close to you, like a family member who knows a lot about you and effectively runs on like the same shared privacy space machine. So that's a human-like model. The life cycle kind of thing of like, can you contaminate the training data? Can you sort of like work at inference time? Can you operate on what they call retrieval augmented generation? So that's basically when you give it private information or extra information to infer on. That's kind of like, humans leaking secrets. Like, as a consultant, people often give me NDA'd information. So that's the equivalent of like doing retrieval augmented generation on me. So the consultant is relying on or the client is relying on my knowledge, but giving me extra data to work with. And then I generate a response based on the extra data. But now I have that extra data, and somebody else with very clever questioning might make me reveal NDA'd information without my being aware of it. So this can even happen like naturally, accidentally, like, in some related conversation, it just so happens and you forget that something that's like not, super sensitive, and it's on sort of the edge of your sort of like cautionary boundary, and you accidentally let it slip that, I don't know, new product is being released next month and you're not supposed to, right? That's never happened to me, but like weaker examples of that sort of thing have happened. And yeah, the attack vector, poisoning, the three top categories of what was it? Data availability, availability, integrity, and what was the third category? Privacy. Yeah, I think that's a useful way of thinking of humans as well. So how do you make a human person sort of like compromise them? So one is availability, like kidnap them so that they're not around. Integrity, which is like, poison their mind in particular ways so that under certain circumstances they become unreliable. Privacy, which is like, steal information they know. So all of it looks extremely human to me. The final thought I had, I think it's related to the points made already about the weirdness of just having one huge, large foundation model class, which is trained on the entire internet, because this is one area which is not like humans. Like humans don't know the entire internet. We have much more narrow but deeper bodies of knowledge around which we're built. And this is actually a big part of human security. So the idea of like security through obscurity is basically that there are 8 billion humans and most of us are too unimportant to attack. And part of that obscurity is that very basic stuff which somebody could easily discover if they bothered to look is secure because they basically don't bother to look. Like my name, address, phone number are probably easily findable by anybody who actually wants to know. But somebody who's running a brute force attack on like everybody in the world is unlikely to just find me. Same thing with like, passwords keep getting leaked with every data exfiltration, but it's probably relatively low risk for any individual because you might not be targeted. So applying the same idea to AI, I think if you have like billions of models that are like varied in minor ways, like they use different data, they use slightly different training paradigms, they use slightly different machine hardware architectures to run on. This will create a kind of variety that'll create security through obscurity for AIs as well. So I don't think we are there yet. And I guess one more point, which is Anurag was talking about what happens when the entire internet gets flooded by generated data and the loop gets closed because AI is now effectively training on its own data. I think this is actually, again, very similar to the human case of fake news. So 15, 20 years ago, you only had like a one-way transmission of like journalists in the field getting real data, then putting them in newspapers, and then the newspapers going to readers mostly in a one-way direction, like, and yes, there were biases and stuff, but it was still like an open loop that didn't feed on itself and get contaminated. And what's happened with social media and blogging and everything else is the loop is closed and poisoning itself. So now fake news is all over the place because people are producing and consuming it without any help from AI. So I think that's kind of like a preview of what will happen when the loop gets AI powered. Anyway, sorry for going on a little long. Scott, if you're back, you can take your turn now. I think you might have been away before.
Yeah, thanks. Good morning. Sorry for the technical difficulty. I did the reading as suggested, the glossary, the intro, then the conclusions. A few of the things that came up were shared in the group, maybe the social and technical laws for ML management and organizing, how designers are to conceive of it. And I was really struck by the specificity of the trends, patterns, problems that can come up when organizations are trying to do something. Something that struck me at the end in section 4 was that no organization or nation holds the data, and how this sort of geopolitical situation is like a very upstream condition that has so many consequences going down the mountain. It struck me, I think Venkat, you had some essay a few years ago where you talked about how servers eat the culture, how there are limited elements that really determine everything else, and the sort of culture eats plans for breakfast is it's popular but discredited. I'm just trying to, think out loud, I guess, about how does this taxonomy maybe disclose or reveal more specific, maybe description of the problem and more accurate description of the problem than maybe these more caricatured, memed discussions of ML and how we can conceive of it. So, yeah, thanks.
All right, I guess that's the first round. And Jenna, you were on mute and listening first round, but do you have like comments now?
I'll chime in just with two things. One is I dropped the links in the channel last night. Excuse me, because I had peeked in there last night, and I went back and found that it was a 2016 short story from Cory Doctorow about autonomous cars getting hacked. That was the first moment for me when I thought, oh right, as soon as these things are independent agents, the bad things are going to happen, either just through accidents. Inadvertent bad coding, of course, but all this adversarial stuff that this article covers. And then just last week or so, I dropped it in there as well. It's part of what reminded me of it. There's a pretty funny scene from one of these disaster movies from the last year, which I did not see, but the algorithm offered me up. And it's this funny little bit where the Teslas have all gone rogue. So if you haven't looked at it, I don't know, it still makes me laugh, even though, of course, it's deadly serious. But the way the movie plays it, it's sort of funny. And then the other thing I think about is for people who are security, white hat people, just the hubris of thinking you could stay out ahead of the bad guys. So, kudos to the good guys who are trying to figure all this stuff out. It seems like a cat and mouse game that, we will just continue to lose, and everything's going to be about, putting up sandbags to prevent the flood that's about to come in. The specific question I have for this group, and I posted about it in the voice chat for today, is I really actually don't quite get what they mean by white box. And is it only when a researcher, for example, gives somebody full access to the model for this kind of penetration testing? Or is it something more trickier than that? I'll hang up and listen. Thanks.
Yeah, I didn't dive in, so I don't know the exact details as well. But from the fragments I saw, I think white box generally means you either know the entire structure of the model. So, for example, there might be an open source framework, so you can look at the code on how the model is trained and how it's used for inference. And in the more severe case, you are allowed to run code on the machine that runs the model at some other privilege level. So there was a DRAM attack, something like row something, that mentioned that if the attacker can run as a user privileged program on the same machine, it can do certain things. So this is kind of similar to traditional security, where if you get access as a regular user, you can become like an admin or super user and then do other things. So I think that's what.
Do you think they're doing part of that as inviting people in order to do this kind of testing, or is it possible that a bad actor finds their own way to white box in? Okay.
I don't think you need to be invited in. Ultimately, these are programs that run on regular computers, just with a lot of GPUs. So all the traditional attacking methods apply here as well. You could figure out how to hack into OpenAI's servers, and then you're inside OpenAI servers, and you can do things that you and I cannot do just with access to ChatGPT. So yeah, you don't necessarily need. Insiders, of course, will have even more ability. Somebody can just take proprietary data from OpenAI and leave the company. But that's any kind of traditional whistleblower or that kind of situation.
Right. People really can get inside the castle. Thanks.
Some of the techniques mention things like, can you measure the loss function or reconstruct the gradient? Some of those require runtime access to the computer's processes as it's computing. So yeah, that's similar to like, you're running, I don't know, Microsoft Word on your computer, and some other program in the background can read the memory that Microsoft Word is using and do things. Anyway, more comments? No second round, huh? Big fat document.
I was hoping Nathan would be here because he really is a security, setting himself up to be in the biz.
Yep.
So one thing that did strike me on the quantized model section of this paper, where they had a line that was saying along the lines of quantized models that typically use like a lower bit integers instead of like a greater bit floating point numbers sometimes could tend to sort of the other amplification could result in lower precision. I thought that was different from what we had discussed previously, but I thought it was interesting that they had thought, at least in this paper, they mentioned that.
It's one of the more like computing specific things that does not resemble human things, I think, the quantization type stuff. Even there, I don't know, there's like a lot of these models use like, very low precision floating points. So that was one of the big ways gains were made. I think we read about NVIDIA's strategy like several weeks ago. So going from like, 32-bit to 8-bit floating point gets you lots of performance gains and doesn't affect performance. It gets you lots of cost improvements and speed improvements, but doesn't affect like quality of performance much. This is a little bit like humans who kind of are like, I don't know, have good intuitions with low ordered information and input. Anyway, all right. Last chance. Any more thoughts? See you guys
Thanks
next
for
week.
finding a good dive.
Yeah, this came from what's his name? The other Ben Evans. His newsletter. It was at the bottom.
Oh, yep, makes sense. Okay.
Bye.
See you, everybody.
Thank you.